Pleasure to be here. We're going to do a talk, it's a thought leadership talk about our experience building high-performance teams from our backgrounds. Myself in the McLaren Racing Formula 1 team and Tun from various technology companies. So just as a quick introduction, I'm the founder and CEO of a tech startup called Quix. We spun out of the McLaren F1 team in 2020. And my background is actually as a mechanical engineer. I spent a lot of time developing vehicle products in the automotive industry before becoming the head of innovation at McLaren Applied Technologies, which is 1/3 of the McLaren group, which also includes McLaren Automotive and the F1 racing team. And in that role, I led the development of our telemetry acquisition platform, which was a Kafka-based data platform. And the development of applications on top of that platform. Tun, would you like to introduce yourself?
Sure. Hey everyone. So my name's Tun Shwe. I'm the VP of Data at Quix. So I've spent a lot of my career at high growth startups. So I was helping leaders in figuring out and implementing their data strategy with streaming technology at its forefront. And I've spent a lot of my career also as a data engineer, so hands in the mud, helping and building teams, leading teams in delivering analytics platforms and AI-enabled products as well. So yeah, so that's the intros out of the way. The format of this talk is more conversational. This is kind of like a simulation of a talk that Mike and I had about 3.5 years ago in a pub in London in the UK. It was a rainy day and the conversation flowed, so we're going to recreate that somewhat for you. It's a restream. In the correct parlance, it's a replay of a stream. So let's start off with the title. So originally I called it 0 to 60. Miles per hour, because that's normally how you measure the speed of cars, right? It's like, what's the 0 to 60 for that car? You want 2 seconds, 3 seconds, that kind of thing. So why 0 to 300? Why did you come in and say, this is how we do it?
Yeah, I mean, that's really because of the background. So as I briefly introduced, Quix and the founding team, so up here I'm with Thomas, Peter and Patrick, we're the 4 founders of Quix. We started it on the 2nd of March 2020, which was quite a fateful period for COVID and things like that. But we'd spent the 3 years before that solving how to ingest and process data using Kafka in a very high performance environment. Since then, we've been fairly well funded. We've grown our organization across Europe, and we're in production with a number of quite interesting use cases, from processing Wi-Fi data in underground stations right through to manufacturing data and financial services. So 60 is just not enough. We want to go faster. Nobody ever wanted slower data or slower anything.
Yeah, no one wants to wait for data. That's what I learned at this conference. I don't know about everyone else here, but yeah,
so
that's
I
right.
upped the speed to 300 to really talk about how we can get to this promised land. And what the promised land was, so at McLaren, we had this vision where we wanted to get to the tip of this pyramid, this tip of the iceberg, where we were able to rapidly iterate on constantly changing data. Now, what does that mean? We go racing 23, 24 times a year. Every single time you go racing, you have the potential to fall back by 1/10 of a second on average. Cars go faster and faster. And one of the reasons that is because you collect new data, you incorporate it into your modeling, you improve your knowledge of the car, you improve your knowledge of the driver. And if you can do that quickly, Monday to Friday, then you have a chance of going faster next weekend. And of course, if you can't do that Monday to Friday, then you have a chance of going slower next weekend. So the place we wanted to get to is this promised land of being able to collect and process and iterate on our data very quickly, and then serve models back to production so we could actually use them in race situations. And that's what this is all about. How do we get there from fundamentals of collecting high quality data?
Yeah, I think 1 week as a period is really interesting because you're constrained by just the format of the race weekend, right? So it's like you have to get it done before the next weekend. I mean, if everyone's familiar with agile methodology and running sprints, like I've worked in sprints that are 3 weeks and 2 weeks. I've tried 1 week sprints where you try and deliver and demo something inside of a week. That's really challenging. So the fact that this is like bread and butter for you is amazing.
Yeah, try an hour sprint. That's quite fun. I mean, the practice session lasts an hour, and then you've got about an hour just to improve the car setup before you go out again.
I'll make some notes. Yeah.
Yeah, it's a bit different. But it all started really from working on good fundamentals. So we, as most people here will know, data comes from good quality. We actually started in a place where we had the ultimate silo. We had literally each engineer had a full copy of the data set on their laptop and their own code on their own laptop. It was kind of out of necessity, so we obviously fly away to races. We collect data and then people get on the plane and fly home. And they want to be working, because we've got this short turnaround time, they want to be working on the plane.
No one talks to each other. It's like ultimate silo. It's just like no talking allowed.
We actually developed a tool called Atlas, which is a fat client. And it's a full analytical suite, which really works on a Windows laptop. And it was to enable this kind of...
So no Linux support, no Mac, just...
No, but it caused chaos as well, because we didn't have a single source of the truth, the team's not collaborating on one data set, and we don't have one code set. So it was really quite problematic.
Yeah, that resonates with me. When I've run teams that try to go fast, siloing is just one of the first things that happens. I think when a company makes an investment in data and a data team, they want that return on investment as soon as possible. And what happens is, let's say if you have 5 teams in the company, like one of those clearly is way ahead of everyone because they've got some of their data understood. And so they zoom ahead to the detriment of all the other teams. So they've got this, it works for me mentality. And that's usually like what you see at the beginning. And you've got to move on from there. You've got to talk to each other. The team's got to figure out like how to work together with the same data, not create duplication, that sort of thing. So
yeah, there's a lot of cultural challenges to overcome, and we, being a technology organisation, we also took a technological approach. So this is when we started to adopt Kafka. We wanted to centralise all of our data into one environment and unify that across our streaming, live streaming from the race, but also all the work we do during the weekend, during the week, where we're collecting data from wind tunnels or simulators or engine dynamometers and things like that. And we decided to start producing all of our data to Kafka and heading upstream to fix quality problems. So one of the things, Tun, that I see a lot in tech is this modern data stack and ETLing like crazy, which is kind of bonkers to me, because in McLaren we actually did a huge amount of stream processing before we landed data in the storage. And when it ended up in the warehouse, it was very, very high quality data tables, which our analysts could use incredibly quickly. And I just see a lot in industry of like storing raw unstructured data and then transforming it. So what's that all about? Why is that the factor?
Yeah, and a few of the places I landed, that was one of the first things I asked. It would be like, what are you trying to measure? And they usually say, well, we collect all the data and then we're going to figure out what to measure later. So that's the road to ruin, by the way. You got to figure out what you got to measure. Don't try and measure everything. So that tells you like an organization isn't really asking the right questions. They don't really understand what good looks like, for example. But I say metrics is getting really good high quality metrics that you can trust, and getting all the data cleaned upstream before it gets into the warehouse. That solves many problems as well, because Kafka is great for distribution. So as a source of truth. That makes sense. So you talked a bit about BI there, like you alluded to BI. So did you have data warehouses? Where was the data? Was it in Excel files and everything?
I mean, we did move from a place where it was a lot of Excel. I mean, you actually see in the automotive industry in general, I've worked in a lot of organizations there, and we will collect data from a test track, and people will store that on a pen drive and basically fly it home on a plane and plug it in and upload it. So there really is still this practice of Excel and very unstructured methodologies around collecting data.
And what if it doesn't fit on a pen drive? Like we're talking lots of exabytes. What's that like?
Well, you just clamp it to your wrist with a sensor.
Okay, like a mafia movie. They just
exactly. Yeah, it's sensitive data, but it's quite remarkable because actually in the industry there's a lot of data competence. There's a lot of skills. As MechEng, we learn how to analyze data. It's bread and butter. You learn that in university. But the data quality side of things is kind of lacking. So improving that was a big advantage for us. And of course we had structured stores, but those structured stores were fed with structured data largely from Kafka. So we made sure that we had cleaning and pre-processing before we stored the data to enable us to do these kind of BI things. So we move up the application layer to thinking about what we do with the data. And Tun, I know that you've worked in a lot of businesses that really use BI at the core. So can you tell us a bit about delivering successful BI projects?
Yeah, so we're now in the batch layer still, and you talked about modern data stack. That's where we normally would have ELT, that kind of approach. I used to run my data teams like product teams, meaning we'd adopt methodologies like user stories. So every kind of task had to describe exactly who it impacted, and it had to express business value. And it had to be very clear about the metrics it was delivering. That enabled the whole team to keep, the rest of the team honest, and to keep stakeholders honest when they didn't know what they were talking about sometimes, or they were asking for too much. So just having a very clear idea of what you're trying to build and what you're trying to measure, that was always at the heart of it. Yeah.
Yeah, I mean, the stakeholders, I think, is really important. In F1, our key core stakeholders, the driver, the race engineer, and the technical leads across the business. And understanding what kind of decisions they want to make and how they use the data is really important. So we could put together analytical tools that they could use to make these quick decisions in between practice sessions, setup decisions, or trying to change the way the driver enters corners and things like that. Yeah. It was really about understanding what business answer they wanted, or business question, and how to answer that most effectively from this complex data set.
On that, actually, because one thing I always advocate when I arrive at places where I start off doing some sort of data maturity assessment, and in many cases I always ask leadership and like quite a lot of the business teams, the business users, to take a course to elevate their data literacy. So that's something I always advocate for. Is that something that you needed to do at McLaren?
Not a lot, no. Like I said, we just have a lot of people in the business who are analytical. Yeah, people who are trained in engineering at university, they just use data. You run models, you look at charts. So that's not really where we had a problem. Much more, I would say, on the IT and technology side, where we had this unstructured. I think it's on the base layer where we had this unstructured kind of environment for collecting and analysing data.
Okay, that makes sense. So, yeah, you started building Kafka quite early. So, how did you get to identifying that as the right solution?
Well, aside from these data quality problems, we also wanted incremental processing. So as sessions are progressing, we're building a view of what the data looks like. And so as soon as the session ends, we can start thinking about making tweaks to our setup, tweaks to our models. So yeah, it was really also about not only just this ingestion of a lot of data, high quality, like making sure we have a high quality data set in our storage, but also ensuring that we've got incremental processing. And that was one of the big advantages that we got from leveraging Kafka in production.
Yeah, a lot of, certainly the startups in the conference hall, you see them talking about incremental materialized views, and you were kind of getting around to doing that like 6 years ago, which is, yeah, quite early on in the game, I'd say. Like, yeah, everyone is still like batching and dealing with data arriving late, but you were getting on that quite early, so that's pretty impressive.
Yeah, it was very cool. I mean, it was a nice time to be experimenting with Kafka, because it was also super early in the ecosystem. We're talking about 2016, 2017. So there's a lot of it we had to do ourselves, which is where we found a lot of the problems that we now try and solve in Quix. So this brings us up onto the next layer, which is all about building automation. So if we can do good business intelligence and we have models, then can we actually build them into our applications, which I think is a big gap now in technology. Is like, how do we automate systems from this data in motion, which is the big value add. It's actually more valuable than just doing BI. You worked on a lot of customer experience projects, Tun. How did you approach the challenge of building automations into your applications, building data properly, data-driven applications?
Yeah, I guess like one of the automations you want to do is introduce something like a schema registry, so that you always have to have a schema as a mandatory part of your processing. That always helps deal with problems upstream, because often, if you're dealing with devices and you do firmware updates, like the schema suddenly changes, things break, and it causes problems in the data pipeline. So things like that help clean it up. So like you even mentioned, like getting all your processing into Kafka before the analysts would get their tables. Did you use schema registries? Did you use anything like that? Those formats?
Yeah, of course. So that's fundamental to the quality that you need to deliver applications in real time. So yeah, really to build a machine learning model, which is building some crash detection, some slip detection, that you have to be able to rely on that, and it needs good quality data to serve it.
Okay. Might be a silly question. What's slip detection?
So a car has 300 sensors, which isn't many. It sounds like a lot, but it's not many. So we describe things using virtual parameters. We calculate missing information on the fly. So slip would be if the car's literally sliding across the floor, whether the front axle or front wheels are slipping or the rear wheels are slipping. It's oversteer or understeer. And you'll calculate slip based on some raw data. So from 300 channels, we create maybe 50,000 columns, I mean, if you like, columns of data. And a lot of that is what we call virtual parameters, but maybe in machine learning, you'd be more calling them features.
Makes sense. It just made me think, one of the other things I change in the design when we start adopting a technology like Kafka is, I think, the common microservices architectures, first of all, it's usually a lot of JSON flying around, so we usually change that format. So Avro supports JSON, but also a binary format, so that gets kind of like the packets over the network, that gets smaller. And the other thing was, you generally build like REST APIs, and with REST, the example I always give is for an e-commerce store. If you have a user and you want to enrich it with that user's order information, that would potentially be network calls to get hit an API to get that user's orders. But in Kafka land, which and its speed is really around sequential I/O, you would co-locate a user by key to its orders, and that just speeds things up when you're doing retrievals. So.
Yeah, it does. So I recently wrote an article about the impedance gap between kind of software and data science, because one of the problems you just described there is, yes, a lot of machine learning models are served and they call an API, but when you have an event-driven system, let's say data comes in from the left and it's event-driven, and then on the right-hand side you've got an application calling an ML model. You've then got a synchronization issue, which is really a butting of heads in data land.
Yeah.
And that was very painful. So we actually moved a lot more of our applications to be entirely event-driven. So calculating features on the fly against the broker and serving machine learning models in microservices against the broker, and making it a pure event-driven architecture. So you're pushing events out to the application rather than calling a REST API to get an ML response. Which, it's kind of different because, today we're seeing, I think, a lot of really API-driven, RESTful-driven approaches to ML in production, which clashes a lot with event-driven systems.
Yeah, and what was when you talk about impedance gap, it always makes me think of in teams where we had different languages. So you might have a software engineering team that knew Java, and then you have the data science team who use Python. So what kind of problems did that cause, like, if any?
It made life very difficult. So we obviously we built this Kafka platform, and we got data flowing quite freely. But then all of our problems began, really, because we had a lot of analytical people. And they couldn't really use it. Was a skills gap then. They couldn't leverage the low-level implementations of Kafka, and also they frankly just didn't want to use Java. And so we found it really hard. There was a very, very big DevOps and software engineering overhead to start building analytical applications on the broker, which I think this skills gap between data being in Kafka and data people wanting to access it and build intelligent applications is another big part of the impedance gap. Part of it's technological, and part of it's really skills. So it's another thing that obviously Quix is trying to solve, which is how do we actually bring more of the analytical teams to Kafka where the data is flowing.
Yeah, that's a good point, because once you have Kafka like as your source of truth, now you have data in one place, and you basically invite the teams to come to where the data is. So each team would build their own consumers to consume from that stream. Often when we say that, they always say, well, that must mean that the number of your streaming applications, your BI, all that grew massively. It's usually never the case because of that impedance gap. It always gets in the way. So it was a language barrier, right?
Yeah, it's not the case. We really hit a barrier where we couldn't build more applications faster. There were just so many problems, even not least like getting data, but testing models. So when you're developing a model in a Jupyter notebook, then it works. When you deploy it to production in a real-time environment, data suddenly starts to arrive slightly differently. Maybe there's time gaps, maybe there's data out of alignment. And these kind of things can cause models just to fail immediately. So there was a lot of problems in just even testing in development and then doing smoke testing before you deploy to production. And all of these things just slowed us down, and they leveraged, or they consumed a lot of our central platform team's time to go out and help data scientists and analytical people to build their applications.
Yeah, you mentioned that about like the makeup of teams. So did that shift as well? Because in some of the teams I built, we realized that we wanted to be more T-shaped, like a multidisciplinary team that, you know, and like the data engineering team adopted this concept of you build it, you run it. So anyone that joined that team, if they didn't know certain technologies like Terraform and how to like create infrastructure and manage it, they would learn it. That we'd practice pair programming, things like that. So we'd make sure that knowledge was shared. So did you have anything like that, a multidisciplinary team?
I think a lot of our journey so far has been technological, but this is where we started to address skills gaps and things like that, and also structural team dynamics. So I led a project where we, for the first time, formed a multidisciplinary team. It was called the Miracle Project, which had an acronym which
no pressure there.
Motorsport Insights and Race Analytics, something or other. But the Miracle was also quite apt because we would say, okay, can we create small pockets of application teams?
Little miracles, not one big one, right?
That can actually build apps without being supported. And what we ended up doing was putting a software engineer in with a group of data scientists and maybe a front-end engineer to actually build on their own an application. It moved us, this structural team dynamics moved us a big step forwards in achieving this goal, but we still also missed it. It still required quite a high number of software-like people to help the analytical people to be able to analyze and ship code to production.
That's true. Like if I think back to around 7 years ago, I remember a lot of my friends who were data scientists, they would be like the first data hire in a company, and so they'd arrive ready to build machine learning applications, but the data was just not available or not collected or in a mess. So like that was when. That was then. I think nowadays we know that there has to be data collected and cleaned up. Like I think that's well understood now. So we are at that point where you would hire data scientists to do their actual job, which is they are subject matter experts, they are statisticians who know how to code. Let's keep them doing that. Let's not have them manage infrastructure and deal with all these things that would be a distraction.
100%. Yeah. I mean, we get back to this promised land now, which is this idea of being able to collect data, incorporate it into our knowledge by training machine learning models and serve that back to production in a week. And
that was a lot of data, by the way. Like if you're doing that, you mentioned you'd have to ship this data. So how did you do that? So between race weekends, so for those unfamiliar with like F1 race weekends, you might have to finish a race and then join the next race the following weekend, which could be in a whole other country. So you might have to cross the sea, all that stuff. So how did you deal with the data?
Yeah, we had quite an interesting architecture where we had trackside servers. Okay. And they would run a complete platform, so a full Kafka platform, trackside. We had 4 of these servers, and they would literally go around the world on boats, and we would schedule that.
Sorry, on boats, did you say?
Boats, yeah, clearly not
not like a rowboat. No. We're talking.
And then we would backhaul all the data over private links back to the factory. Right. And so when we started out, we had a lot of people would fly to races. But now much fewer people, and there was a couple of dynamics driving that. One was cost coming from the regulations, and the other one was 3. Second one was environmental reasons. You just want to stop flying people around.
Oh, that's good.
And the third one being people's health and sanity, because if you're doing 24 races a year and many of them are long flyaways, you're really under pressure to jump on planes and fly and work like crazy. So overall, Kafka has actually led to better people's health.
Wow, let's put that on a t-shirt.
Definitely.
I like that, boats, like my experience of boats is they have to leave on time. So like getting it in a timely fashion is also great. And I guess it also solves the late arriving data, because you can just have a drone drop off like the extra data.
In a future world, maybe.
Yeah, maybe.
Yeah, so we ultimately got here to this, or at least close towards this promised land. It was a combination in the end of technological advancement, but also skills and structural, so changing the way our teams worked. Yeah. There was a lot of I guess, effort that went into that, and a lot of energy that we couldn't even deliver because we were busy. And everything that we thought about there is really being ploughed now into Quix to help organizations to really deliver applications at this level and bring more of the analytical and AI people into the Kafka environment to build these real-time applications.
Yeah, the conversations are very different. I would say even in the last couple of years, they've kind of changed because everyone does online influence for machine learning. So everyone can do that through an API or otherwise. But not everyone can do the online training part. So to incrementally look at every data point that comes in and use that to adjust parameters in the model. It's really hard, but we're at the point where there is appetite for it. So that tells me a lot of the previous work has already been done and they want to get to the next level. So that's reassuring.
Yeah, very cool. So I think we are about at the end of our presentation. There's a quick few takeaways for you. So number one, you can't build anything without strong foundations.
Yeah, absolutely true. Like trust, eroding trust. Once it's gone, it's really hard to get back. So yeah.
And this was both technological foundations, but also skills.
Yeah, so picking Kafka was a good choice, right?
Batch systems are really great for human decision making. If you're talking about fairly high latency, I mean, there's very few humans in the world who can analyze constantly changing data. F1 engineers maybe are a rare breed, but for the rest of us, just looking at
1 hour is good.
1 hour is fine, even a day.
If you're running a campaign, maybe like twice an hour, but yeah, a day, an hour fits the human mental model for sure.
And then there's higher value to be gained from leveraging your streaming infrastructure in your application. So if we can automate systems, if we can make decisions on the fly, then you're going to have higher value outcomes from your data investments. And that's where Kafka and streaming comes in.
Absolutely, yep.
And then the final one is about the structure, so teams. I mean, I love this term, modern application team. We see increasingly that teams are able just to build cool stuff with maybe a data scientist, a software engineer, and a front-end engineer. Just 3 people's enough to build quite incredible, powerful real-time applications.
Yeah, like I think concentrate the skills in like where they should be spending their time really and skilling up. So yeah, having data scientists looking after infrastructure, that's probably not what you want. That's a great way to make data scientists leave the room and your company. So I would say, yeah, have them solve really difficult problems as knowledge workers. That's a good outcome.
And give them the tooling which they need to develop their applications. So that's all from me and Tun. Quix is tooling which helps you to build real-time ML pipelines. You can try it for free. We're at booth number 314 with a few demos. So if you have any questions or want to come and learn more, come over and see us. We're just across there in the hall. Well, I hope you enjoyed the format. We tried to experiment a bit and change it and make it more of a dialogue. Thank you very much for your time. I'm here all day, so it'd be good to talk to you more in detail offline. If you're around, come and see us.
Yeah, thanks folks.
Thank you.